So at the end of the day, they were saying, find the lengths of the sides of the triangles. So I'm guessing they meant the lengths of the sides of all of the triangles. And this, what they have here, is all of the information that they gave us, apart from one thing. And that one thing is that the radius is 6 centimeters. So that tells me that all of these guys here are 6 centimeters. Right? And then we can see that they gave me some information here. Right? The first thing I noticed, and remember, you know, with circle theory, there's a whole bunch of different theories, and you just often wonder which one would apply to this, which one should I use first, you know? And it doesn't make sense going and trying to remember all your theories, right? The first thing you should do is see, well, what do I notice? I notice that I have a huge triangle here. That is what the first thing I noticed, right? And I noticed that this angle is 66. This angle is 54. So that means that I could find what this angle is over here, right? So that angle, what does that work out to be? Anybody? Calculator lady. 180 minus. Thank you, calculator lady, for being so fastidious in your job. Right? 60 degrees, yeah? So this angle on this side, this full angle here works out to be 60 degrees. Okay, so that is the first thing I noticed. Well, actually, the first thing I noticed is all of the radius is 6. All of them. And the second thing I noticed is the big triangle have these angles here so that I can find that angle. Okay, good. The third thing I noticed is inscribed in a triangle. The sides touch the triangle at the points X, Y, and Z. So these points here are tangents. That is what I noticed. They're touching it at one point. And that means that now I can start to think, well, what do I know about tangents? Well, tangents always touch a radius at 90 degrees. So this is 90 degrees here on both sides. This is 90, this is 90. This is 90, and this is 90. Okay, right? So because of that now, I can notice that, well, this is a 90-degree triangle then, right? And that, you know, that is a good thing to know. This is also this. Wow, look, they're all 90-degree triangles. That's a nice thing to note. Maybe I might need that in the future. I don't know. But 90-degree triangles will open up the world of trigonometry and Pythagoras theorem, right? What would really help though is I have this big angle here, but I don't have this small angle here, which is the angle for just one of the triangles. So is there a way for me to get that small angle? Well, let me see, because if this is equal to this, that means that if I draw a line from that point to that point, this is going to be an isosceles triangle. If this is an isosceles triangle, then that means that this bigger triangle is also going to be isosceles. Simply because I know from one of the theorems that if I have two tangents from two different points and they touch at one point here, those two tangents are going to be equal. Any two tangents that meet each other will be equal. So I can see here that this is an isosceles. This is an isosceles. And so this will be bisecting the isosceles. Right? So that means that this angle here is equal to this angle here. That means that this angle here is equal to this angle here, which means that this angle here will be a half of 66. So a half of 66 is 33. Everybody understands how I got that 33 degrees? Scotia, Caitlin, Shazay.
Yes, sir.
Right? So that means that this is going to be 33 on this side. And I apply the same reasoning for all of them. So here, half of 54, what is 54 divided by 2? 54 divided by 2 is 27. So that means this is 27 and this is 27. Yeah? So that means that this is 30 and this is 30. So now, if I have this is 30, this is 90, I could find out what this is, right? So 30 plus 90 is 120, 180 minus 120 is 60. So that means this is 60. And because this is 30 and this is 90, means this is also 60. Yeah? This is 90, this is 27, so 27 plus 90, 117, 180 minus 117 is 63. That means that this will also be 63, right? And if this is 33 and 90, right? 33 plus 90 and 180 minus 123, 57. So that means this is going to be 57 and this is going to be 57. So you notice I didn't really even start to tackle the question yet, you know. I just looking at things that I noticed and seeing if I could remember any theorems pertaining to those things that I noticed and seeing if I could get more information. So you can see here that once I decided that, first of all, the tangent gave me this right angle here, because of the theorem that a tangent and a radius will always make a right angle. And because of that, the second theorem, that two tangents meeting will always be equal, right? That is what led me to believe that it's an isosceles, and hence I could split this angle 33 and 33. And because I now know the 90 and the 33, means I could find this angle over here. I don't even know if I need any of this information, but this is what I can find. So you want to find everything that you could find before you even start to answer the question. Now, I want to check if I'm correct, because next thing you know, I'm wrong. I could be wrong. So if I'm correct, then all of these angles added up should give me 360 degrees. So let's check. 60 plus 60 plus 63 plus 63 plus 57 plus 57. Boom, 360 degrees. So because I got 360 in the middle here, means that I am now confident that all of my theories or all of my assumptions are true. So now I have right angle triangles and I have the angles for them, and guess what? I have one side, so I have this side here, 6. Yeah? So let's just look at this right angle triangle alone. Let's look at this one alone, right? 57 degrees. I have one side which is 6. And they say here, find the lengths of the sides of the triangles. So that means that if this is the right angle, this is the hypotenuse over here. So, and this here, I could find these two sides. So let's find this side. If I find in this side, we could use 33 as the angle. So if we're using 33 as the angle, let's go so ka toa. I don't have to use 33, I could use 57. But I'm using 33 as the angle, which means this side is going to be the adjacent, and this 6 is going to be opposite. So opposite and adjacent is tan. So therefore the tan of 33 is opposite, which is what we want to find, over the adjacent, which is 6. Opposite is 6 tan 33, which is tan 33 times 6 is 3.89. Now we call it 3.9. right? It may even be 4. So I got this side to be 3.9. But guess what? This side is equal to this side. Remember we were just saying that? So that means that this side is also 3.9. Okay? And this here is also 6. Because it's a radius. Now I could find my hypotenuse, which both of the triangles share the hypotenuse. So I could find the hypotenuse to be, well, let's see what I can use for hypotenuse. Let's use, if this is the hypotenuse, we could use this for adjacent, and therefore this angle 57 is adjacent to the 6. So we could use cosine, adjacent and hypotenuse. Right? So the cosine is equal to adjacent over hypotenuse. The hypotenuse is what we want to find. So that means that the hypotenuse is equal to the adjacent over the cosine of 57. Right? 57 here is adjacent to 6. So that is why I use the adjacent, right? The adjacent, by the way, is 6. So therefore I can work out my hypotenuse to be 6 divided by the cos of 57, which is roughly around 11. So we could call this side 4 and we could call the hypotenuse 11. Right? So I actually figured out, once I figured out one triangle, well, it'll all be the same for this triangle. Then I'll just have to figure out this triangle and it'll be the same for this triangle. And once I figure out this triangle, it'll be the same for this triangle. So now I could find the sides of all of the triangles using trigonometry, because I was able to find all of the angles and I had one side, which is the radius. These are a little easier. Find the angle marked in the common letters. So we have to find this angle A. Shazay, Scotia, any ideas? We can see here that this is a diameter. So this is passing through the center. So any ideas? Sorry. Look at it and think about what you know. Look at what they give you here. You know that this is a diameter. Oh, again, well noise from Scotia there. Scotia, have a party by you there?
No, it's just so funny.
Yeah, I hate them people, huh? Yeah, I really can't take them on. Yeah, so what you were saying? What happened with it? It's pretty?
It's like...
Right. So that what Scotia is saying there is that when you have a semicircle, the angle subtended by a semicircle will always be 90 degrees. Right? So that's one piece of information that we got there, that this here is 90. So if this is 90 and this is 74, then we could find what this is, because this should be 180. Right? So 90 plus 74 is 164. 180 minus 164. This little guy here is 16 degrees. Nice. So what now? And then we have, oh, here we go. Alright, this one might help us. The tangents, the angle between the tangent and a chord. Well, let me see. Yeah, this is a chord, and this is the tangent there, and we have the angle between the tangent and the chord. Alright, so the angle between the tangent and the chord at the point of contact is equal to any angle subtended by the same chord in the alternate segment. To any angle subtended by this chord, so the angle that is created by this chord, right, which is this angle Y here, right, in an alternate segment. So this chord, remember the elements of a circle. This chord breaks up the circle into two segments. The smaller segment, which we call the minor segment, where this angle is. And then we have the larger segment, which we call the major segment, where this angle is. So that is why they say the alternate segment. Yeah? So what they're saying, forget about this triangle here. Just look at this one alone. It looking familiar? Right? So you could see here, right, that this is the chord. You all seeing this, right?
Yes, sir.
Yes, sir.
So this is the chord here. Right? And this is the diameter. We know that this is 90 degrees, yes, right? But look at that, right? Look at that, and now look at this. This is the chord here, right? This is the diameter. This is 90 degrees. Yeah, so the chord, and then we have the angle created by the chord in the alternate segment, and they're supposed to be equal. And now look at this here, right? The angle created by this chord, right? So we have this chord. The angle created by that chord is this angle here, right? If I want, I could cut it so, like this. Remember, the angle subtended by a chord is all equal, right? So all of these angles here will be equal, right? So the angle subtended by this chord, so all the time we were looking at it from the perspective of here. So this here is the semicircle, and it forms this angle over here, right? Which we saw was 90 degrees, angle subtended by a semicircle. But now we're talking about the angles subtended by this chord. So from this point here, you can see that the angle subtended by that chord is this one, right? And the last theorem says that if I have a tangent meeting at a chord, then this external angle is going to be equal to any angle that's subtended by that same chord. Sorry. So if this chord formed this angle here, this angle would be the same as this one. If this chord formed this angle over here, this angle would be the same as this one, would be the same as this one, would be the same as this one. You all get what I'm saying?
Yes.
Right? So therefore, because of that last theorem, this here is 74 degrees. This here is 90 degrees because of the first theorem, right? And now we can easily find that. It's 90 plus 74, 164, 180 minus 164 is equal to 16. Yeah? Shazay, how you feel about it?
Well, originally I was thinking, I don't know if it means that I was thinking about it's going to be in the interior opposite rule when I was looking at the 74 degrees.
The interior opposite, right? But that interior opposite is only work for a cyclic quadrilateral, which is not what we have here, right?
Yes, sir.
And even when I try to draw a cyclic quadrilateral, right? If I try to draw that, because this is subtended by a diameter, means that this is going to be 90. So you see here that this doesn't work when you have this here as the diameter. So it kind of off, right? So what it is we have to use the last theorem. The last theorem states that the angle formed by a tangent, the external angle formed by a tangent and a chord, is equal to the angle subtended by that chord. So if you take the chord from these 2 points, you'll see that this is the angle being created by that chord, and therefore that will be equal to 74. This is 90, hence this is 60. Right? So let's see if we could tackle this one here. Any ideas for this one? Where will the 78 be?
Opposite in 52.
Here?
Yeah.
Right, so this here is 78. Yeah. And why? Because this is the tangent and this is the chord. And the external angle created by a tangent and a chord is equal to any angle that is subtended by that chord. So this is an angle, or I could have had this angle subtended by that chord, or I could have had this angle subtended by that chord. They would all be 78. Yeah? So because of that now, I could tell that this is 78, and that means that I could find C. And where is C? What does C work out to be?
40 degrees.
Yes. And if C is 40, then what is B? 62.
Yeah.
Yes, sir.
Right? And look at it. It's the same thing. We didn't even have to work it out, right? This here is the tangent. This here is the chord. This here is the external angle formed by the tangent and the chord. And this 62 here is the angle formed, subtended by that chord. So therefore this 62 is equal to this 62. They go as in? Yeah?
Yes, sir.
So we could actually just look at that and say, well, this is 78, but we didn't even need this 78. We could have just look at it from this chord and say, well, okay, well, this is the external angle, so this is 62 because this is subtended by that chord. And once this is 62, then we could have found this to be 40. We didn't even need the 78 over here, right? But it's good that Scotia saw it, right? Last one, it looked like we have a cyclic quadrilateral, and oh, it looks like we have some parallel lines here. So let me hear you, because 56 is between the tangent and this chord, and right? So this chord does not subtend this angle. From this point and this point, this chord subtends this angle, doesn't it?
Mm-hmm.
Yeah, so this here will be 56 degrees. Right? So this will be 56 here. Right? And anything else?
Would the angle at the top, well,
This one here?
would it be 90? Yeah, would that be 90 degrees?
It absolutely would be 90 degrees, because if we look at this diameter passing through the center here, the semicircle, that is the angle that is subtended by a semicircle. So this angle is 90. That means this angle will be 90. Right? Anything else?
Would the angle next to be 34 degrees then?
Right, so what, you just minus 90, 56 from 180?
Yes, sir.
So this is 34 degrees, yes. Now what?
No.
This parallel line would be the
Right, so these two are parallel. Alright? And if these two are parallel, then this is the transversal crossing the parallel. Right? Get what I'm saying, Shizzy? So these two are parallel, and this is the transversal, right? And what do we say when we have parallel lines and we have a transversal crossing? These two here are co-interior, right? Co-interior, what do we say about co-interior?
They add up to 180.
Co-interior are complementary. They add up to 90 yet? Is it 90 or 180? No, it's 180. 180, right? Are these two co-interior? 56 and 34. Is that co-interior?
Yes. No.
Nope. Nope. The co-interior would be if this is the transversal. Look at it. We have these two parallel lines and we have this transversal cutting so, right? So we have the 34 here, right? No problem, right? But all of this is not 56. You know, you see we have this line cutting down here, which means only here is 56. And?
Yes, sir.
Right? So that means that all of that is not 56. But what I'll tell you for sure is if we have this 34 over here, then this little angle over here will be 34 because alternate angles are equal, right? So if this, and if you look at the Z here, this is the Z. Zoop, zoop, zoop. So if this is 34, and that means that this is going to be 34 over here, right? And that means that because you have this line cutting 90 degrees and this line cutting 90 degrees, right? Here and here, and they're both parallel, means that if this is 56, then this is also going to be 56 on this side there, right? And once you find this 34, you can just do the 3490 thing and found your 56 there, right? 180 minus 90 plus 34, 56. Right? So it has different ways that we could look at it. Scotia, Shazay, how do you feel about this one?
Okay.
Right? So what we saw with this one is that this 56 here is the external angle to this chord. This chord is subtending this angle, so therefore this angle is 56. Right? And if this angle is 56 and this angle is 90, then this is 34. Right? And if these two lines are parallel and this is 90, you could easily say that these two triangles are congruent. Yeah? And that is something that could easily be said, especially since you have them parallel. So since this parallel means that this is going to be 34 because this will be a transversal. So therefore, this will be alternate to this, right? And because this is 34 and this is 90, you could do the 180 thing, and you could find this to be 56. So let's look at this first bearings question here now. A ship leaves port A, so port A is over here, right? And sails 52 kilometers on a bearing of 044 to port B. So they're telling us here that this is 52 kilometers, this distance here, but where is the angle of 44 degrees? Where should I put that angle? Soraya or Caitlin? Let me see if I can remember. Because it's leaving the port A on a bearing of 44 degrees. That is the direction that it's going. So where do I put, is that angle, is it here? Is this 44 degrees? Right. In bearings, remember when we're talking about bearings, if it is that you have a certain position here, call it a port or a ship or whatever, we always measure bearings from the north line. Right? So if this is B here, right, then from port A, you're traveling to port B at a bearing measured from the north line. Right? So this from the north line is the bearing of 044. That's all you really have to remember for bearings, right? So when they say that the ship leaves port A on a bearing of 44 degrees or 044 degrees to port B, that means that this angle here is 44 degrees from the north line, right? So the ship then changes course to sail to port C. So you can see the ship started going this direction here, right? 72 kilometers away. So I guess they're saying, because you know how we misread the question last time, so I'm trying not to do that this time. So tell me if I'm wrong, eh? But is this 72? Is that what they're saying? Yeah. 72 kilometers away on a bearing of, so the ship then, so it at point B, and then it changes course. So from port B, right, to port C is 72 kilometers away on a bearing of 105. So that's this angle here, which looks 105-ish. It definitely looks more than 90. Yeah, so that looks like 105. Right, okay. So on the diagram not drawn to scale, label the known distances traveled and the known angles. So you can see here, that was a 2 marks that you would have lost if you didn't put the angles in the correct place. Yeah. Determine the measure of angle ABC. So angle ABC is this one here. How are we going to find that angle? Anybody? This is actually quite easy. You notice this one here is 2 marks. Very good, very good. So Scotia realized that this is the north line, and this is also the north line, and so therefore these 2 lines should be parallel because 2 of them is north. And if these 2 lines are parallel, then this is your transversal. And if that is the transversal, then that means that this angle and this angle are co-interior angles. And co-interior angles are supplementary, they add up to 180. So if co-interior angles add up to 180, then this angle is what?
136.
136. So if this is 136 and this here is 105, then this here is angles around a point. All of them should give me 360. So this works out to be what? 119. Like a boss. Shazay, how you feel about this? You didn't get that. What did you realize that the 2 north lines were parallel? Right.
Well, I didn't know if I was correct. I just had 46 by 44 with this one. And then after that, just the house.
You had 46 over here.
Yeah.
Why?
I don't know. I was trying to find the total measure of the entire angle. So I take away 44.
From 90, right? But at the end of the day, this question didn't say anything about C being east. If C was east of A, then you would have had the 90. And?
Yes, sir.
But this question didn't say anything about C being east of A, so you cannot assume that this is 90, and it certainly does not look like 90, right? So you understand what Scotia did there, right?
Yes, sir.
Right, and good job, Scotia, for seeing that. And Shazay, don't worry. I was actually impressed with Scotia for seeing the parallel lines thing. It's not something that you would have thought of if you didn't see it before. But now that you have seen it, I'm sure you'll never get fooled with that again. Right? So all of these north lines are actually parallel. Yeah. So ABC is 119 degrees. Good job. Next is calculate to the nearest kilometer the distance AC. So I have to find AC. What am I going to use for that? So watch. So if this is the angle A here, that which we don't have the angle A. But that means that this 72 is the side A, right? First thing to do is label. if this is the angle B, which is 119, then that means that this side is the side B, opposite the angle. That is what we want to find. We want to find side B, right? If this is the angle C, which we don't have, then this here is the side C, which is opposite to that, right? So how did you use the sine rule? Because the sine rule, if let me just say I have A over sine A equals B over sine B, and I want to find a side. If I want to find a side, I have to have two angles. Yeah? I don't have two angles, I only have one. So how did you use the sine rule then? Tell me.
I found the angle A and factor.
For angle A, this little angle here is 46? Or the whole thing, or that little angle. How did you do that?
Minus 44 from B.
No. Why? You assume that this was 90?
Yeah.
No, you can't, because they didn't say anything about C being east. If they said that C was east of A, then you would have had the 90. No. So, actually, in this case, all you had to do was see that, hey, I have two sides and the included angle, and yeah. So if I have two sides and the included angle, then I could just use my cosine rule, right? So the cosine rule is B squared is equal to C squared plus, oh, well, let me put A first. A squared plus C squared minus 2AC cos of B. And you see there that we have everything that we need, and you understand, Scotia?
Yes, sir.
Right? So there is no way I could find out these two angles yet, right? But when I find this side, well, then I could use my sine rule to find the other angles, no problem, right? But I'm glad that you make the same mistake that Shazay made, because you'll never make that mistake again, right? So now we can see that B squared, which is the side we want to find, is A squared, which is 72 squared, plus C squared, which is 52 squared, minus 2 into 72 times 52, cos of B, which is 119. Remember, this entire thing is one big term, as one big unit, right? B squared is equal to, I'll do 72 plus 52 first, so 72 squared plus 52 squared. I think I really need to get a new calculator later. That is 7888. Alright, minus, now I'll do 2 times 72 times 52, 7488 multiplied by the cos of 190. Right? So now I don't have anything to carry across, and nothing like that. B squared is the one I want to find, so 7888 minus that multiplied by the cos of 119. What is that? That's not cos of 119. Right, it's the cos of 119 is a negative, right? So multiply by 7488. So I actually get in here, because remember I'm minusing this. So when I work this out without that minus, when I work this out, I got minus 3630.3. Right? So sometimes, yeah, you could get cos and sine to be negatives. Yes, you can. Definitely sometimes, right? So I have minus, and of course B squared will be minus, and a minus is a plus. So 7888 plus 3630.3 And that gives us this ugly number of 11518.3, and therefore B is equal to the square root of 11518.3, which is the square root of the answer, gives me 107. And it definitely looks like it could be over 100 compared to that 72 and the 52. Yeah? So this here we get to be 107.3. So Shazay Scotia, you understand what I did here? Right.
Yeah.
The only thing that you really had to know about bearings is that bearings are measured from the north line. So if they tell you a bearing of 44 degrees, that means that from the north line, this traveling direction will be, the angle will be here, right? From the north line, right? Bearing of 44 degrees. So that's the outside angle, not the inside angle here, right? And then from C, from the north line, from B, they go into port C at a bearing of 105. So you notice it's from the north line again. That angle is 105. And that is all you really have to understand with bearings, right? The rest of bearings, that's the only real thing you have to know with bearings. And the rest of bearings is actually is either, you know, parallel line theory or angle theory or sine and cosine rule. Bearings question is a question where you would most likely have to use your cosine rule. You'll most likely end up with a situation. And remember I said that once you see two sides and the included angle, you could think about the cosine rule. You could also think about the area rule, right? To find the area of a triangle, right? So all of these things is a lot to remember. Show that the bearing of A from C to the nearest degree is 260 degrees, right? So the bearing of A, so you're going from C to A. A lot of people would say the bearing is this here, but no, right? It's not that from the north line. Remember, this is the other thing. From the north line, if this is A and this is B, then the bearing will always be measured in a clockwise direction. So if B is over here, then this will be the bearing. But if B is over here, then guess what? From this north clockwise, this will be the bearing to get to B. So with bearings, you're measuring from the north line and you're always measuring clockwise. So what this question is telling you, now that you have all of this information in front of you, they tell you to prove that when the ship go from C to A, from the north line here, the bearing, which is actually this angle here, that this angle is 260 degrees. So what they're asking you to do is prove that that angle is 260 degrees. How am I going to prove that? Give me a strategy. Talk me through. Where is it?
Minus 160 to get that.
Right. So what Scotia's saying is that this north line is parallel to this north line, right? So that means that this 105 here is co-interior with this here, and co-interior angles add up to 180 degrees, which means that this here is what, 75 degrees?
Yeah.
So we have 75 degrees here, right? We can't use this 260 here. In all of your calculations, you cannot use the 260. Why? Because they're asking you to prove the 260. Yeah? So you cannot use it if it isn't true. And it isn't true. The only way it could be true is if you prove it. So you have to find a way to show this is 260. So you cannot use the 260 in your calculation. You have to end up getting 260, right? So what now?
Find the angle B.
So find for this angle here. So if we could find this angle plus the 75, and then we minus 360 from it, we should get 260. So the question is, how do we find this green angle here? What do we do now?
We'll do cosine rule.
The cosine rule, no, right? I wouldn't use the cosine rule because it have an easier way, and the easier way is the sine rule, right? The sine rule, I want to find angle C. This is angle C. I have the side C, yeah? I have the angle B, and I have the side B. So I could say that B over sine B is equal to C over sine C, and this is what I want to find, right? So I have the angle C and the side C. I have the angle B and the side B. So now we could say the side B is 107.3 all over. Now, if you wanted to use the cosine rule, remember what's the cosine rule? The cosine rule is blah 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 squared is equal to blah 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 squared plus blah 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 squared minus 2 blah 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 blah, and then the cos of C over here. And you would have had to make the cos of C the subject of the formula and all kind of madness. So yeah, you could have probably used the cosine rule. You would have had to have the side C. Do we have the side C? We have the side C. You would have had to have your side A and B, yeah. We have all of the sides. So we could have used the cosine rule, definitely, right? But the sine rule is a lot easier here, we can see, right? So over the sine of B, the angle B is 119. So the sine of 119, and that is equal to C, which is what we want to find. No, C, the side C is 52, and it's the angle C is what we want to find, which is the sine of C. So now with this, we could cross multiply. When we cross multiply this and this, we'll get the sine of C times 107.3 is equal to 52 times the sine of 119. Therefore, the sine of C is equal to 52 times the sine of 119 divided by 107.3. That sounds like a radio station, right? So therefore, C is equal to the sine inverse of whatever we get for the answer here, which is, if I had a calculator lady who is competent enough to work this for me, and I have one who I believe is very competent, but she might just be lazy, right? Divided by 107.3. Laziness is something that can hardly be tolerated when it comes to calculator ladies. And we have the sine inverse of 0.423, which gives us C to be sine inverse of the answer 25 degrees, let me see. Right? So we see in here that C is 25 degrees, 75 degrees on the outside, so 25 plus 75 is 100, and of course 360 minus 100 gives us 260. So we just proved that there is 260 degrees. Shazay, how do you feel about this?
Okay.
You understand everything?
Yes, sir.
You have any questions?
Yes, sir.
Is there anything you did not understand?
Yes, sir.
Scotia, you understand everything as well?
Yes, sir.
And then I have my two fuzzy head people who are content with misunderstanding. Fuzzy head people, I hope all you're good.
Yeah.
Right. So let's tackle this one here now. Right. And this one isn't really a bearings question. This one is just a question on trigonometry, right? So the diagram below, not drawn to scale, shows a quadrilateral, right? QRST, right? Oops, where is it? Right? In which QS is 7 centimeters, yes. ST is 10 centimeters. QT, which is the name of my kitty, by the way. My kitty name is Cutie. She name is QT Mao. That's her name.
Yeah, that cat.
Yeah, she just be assistant teaching me sometimes. But all you don't see because it was be on the screen, right? So it looking like they're giving us all of the information we have here. QT is 8 centimeters. The angle SRQ, which is this angle, is 60 degrees. The angle RQS is 48 degrees. All right. Find the length of RS. The sine rule. I would not use the cosine rule because I want to have two sides and the included angle in order to find this side. That is what you're looking for the cosine rule, right? So you see back on this one here, how I had these two sides and the included angle. So I used the cosine rule to find the other side. So that is what you want to look out for. And here you can see that if this is the angle Q, this is the side Q. If this is the angle R, then this is the side R. And I have the side R, I want to find the side Q. So Q over sine Q is equal to R over sine R. Right? So what do I want to find? I want to find this side Q. So that means I can just throw across. So Q is equal to R over the sine R multiplied by the sine of Q. So Q is equal to R7 all over the sine of R, which is 60, multiplied by the sine of 48. I'll just use my own calculator here since I have nobody to help, you know. Nobody willing to sacrifice their fingers for the aid of better mathematics. Multiply by sine 48, approximately 6. So we could just call it approximately 6 centimeters here. 6.006. So that's pretty much 6, right? So, Shazay, you cool with that?
Yes, sir.
Easy stuff, right? Alright.
Yes, sir.
Next one is the measure of the angle QTS. So QTS is this angle here. How do I do that?
Oh, sine rule.
Yes, and not the sine rule, because you know sine rule is A over sine A is equal to B over sine B, and generally you need two angles, right? I want to find this angle, but I don't have any of the other angles in this triangle, right? So sine rule seems a bit iffy, right? Remember cosine rule, I was saying that usually you want to have this side and you want to have this angle in order to find this side. But you know, with the cosine rule, if you have this side, then you could find this angle. And so if you have all three sides, you could definitely find that angle over there using the cosine rule. So the cosine rule, let's call this side small t, right? Let's call this the side small q, because it's opposite the q, and let's call this s, right? And we want to find the angle t. So the angle t will have cos t at the end, which means that I'm supposed to have t squared at the beginning. So t squared is equal to s squared plus q squared minus 2sq. Make sense?
Yes, sir.
Alright, Scotia, you okay? Alright, so now we can plug in some values. T squared is equal to s squared plus q squared minus 2sq cos of t. Alright, so let me just work out some of these things here. 7 7s are 49, 8 8s are 64, plus 100, minus 8 by 10 is 80, times 2 is 160 cos t. So therefore 40, let me just flip it over one time. Alright, so I'm gonna have 64 plus 100 is 164, minus 160 cos t is equal to 49. So now I could take the 164 and flip it across. Minus 160 cos t is equal to 49 minus 164. Minus 160 cos t is equal to 49 minus 164 is negative 115. So therefore cos of t is negative 115 divided by negative 160. Negatives cancel, gives me 115 divided by 160, 0.71875. Therefore, t is the cos inverse of 0.71875, which gives me the cos inverse of that is around 44 degrees. So Scotia, did you try this this question?
Yeah, that's helpful.
Alright, lovely. Very good. I'd like to hear that. Shazay, did you try this question?
Yes, sir.
And you got the answers?
No, sir.
Oh, what you do wrong?
I was trying to use the sine rule to get out the part with formulas.
Alright, even though you said the correct thing in class.
Well,
Right.
I say cosine because I realized I wasn't getting it with sine.
Right, and why weren't you getting it with sine? Because you didn't have enough angles, eh?
Yes, sir.
So you probably went and tried to do all kind of circle theory thing to find these angles, eh?
Yeah, something like that.
Something like that, yeah. When really the cosine rule. Just remember, if you have a situation like this, right, you're dealing with cosine rule. Yeah?
Yes, sir.
Sine rule, you need A over sine A is equal to B over sine B. So with sine rule, you need to be dealing with two sides and two angles. Yeah?
Yes, sir.
So, good job there. Last question of the day. Ooh, this one looks a little bit scary. This one looks scary. A boat leaves A. So I'll put the point A. And travels, let me put my north line one time. And travels a distance of 50 kilometers on point to point B at a bearing of 135 degrees. So if this is 90, 135 might be here, so the point B. So therefore this is 135 degrees from the north line. Right? The boat then changes course and travels for, so they give me the distance of this as 15 kilometers. Right? The boat then changes course and travels a distance of 8 kilometers to point C on a bearing of that. 60 degrees. So if this is the north line, I'll measure 60 degrees, and this will be my bearing going to C, and C is 8 kilometers away. So maybe I shouldn't draw C that long, right? So over here, 8 kilometers here, and this here is my point C, right? Illustrate the above information clearly on a label diagram. So we have it here. Of course, it's not particularly neat, but let me see if I could draw it a little neater actually. Okay. So that was just a sketch, a scrappy sketch of it, right? So we have the point A. So this is the point A, and this is my north line, north, right? And it travels a distance of 15 kilometers on a bearing of 100. So from this north line, 135 degrees should be about there. So, and this is the point B, which is 15 kilometers away. I'm just trying to be neat about it. 15 kilometers, right? And then this is the north line here. So from B, it travels 60 degrees to point C, which is 8 kilometers away. And now we have this diagram here. Illustrate the above diagram clearly, just now. Illustrate the above information in a clearly labeled diagram. The diagram should show north direction, so I get our 1 mark there. The bearings of 1, 3, and 60, so I get them 2 marks there. And the distances of 8 and 15, so that was an easy 5 marks there, right? So calculate the distance AC. So I want to calculate this distance from A straight to C, right? So how am I going to do that? Cosine rule, but do I have this angle here? I could definitely use the cosine rule for that, but the cosine rule, I have to have this angle here. How am I going to get that angle there? Remember, if this is north and this is north, they're parallel length.
Yeah.
Right? So therefore, we're dealing with this here being co-interior to this end. So if they're co-interior, then what is this angle going to be? So this is 45 degrees. So therefore, what is the angle ABC? So the angle ABC is what?
105.
105 degrees, right? So now that we have 105, we have the angle. We have the 2 sides on either side. Then we could definitely use the cosine rule. So let's call this the side B because it's opposite the angle B. This is the side A, and this is the side C. So we can see here that the cosine rule, we want to find B. So B squared is equal to A squared plus C squared minus 2AC times the cos of B, right? B squared is equal to A squared, which is 8 squared plus 15 squared minus 2, 8, 15, the cos of 105 degrees. Shazay, you understand up to this point?
Yes, sir.
Alright, no questions. Just stop me if you start to get fuzzy, right? B squared is equal, I can just work all of this out one time, 8 squared plus 15 squared. This entire thing gives me 351.12. I don't know if I get that right. I just punched this entire thing into the calculator, right? So I'm not sure if that is totally correct. So somebody, maybe a fortunate calculator lady, could double check it for me. Because if B, but yeah, it looks to me correct because we're talking about the square root now of 351.12. The square root of the answer, which gives us 18. and 18 kilometers, 18.74 kilometers. It seems to be right, because if this side is 15 and this side is definitely longer than 15, so that side would probably be 18, right? So I would bet that this is correct. So we found the distance AC to be 18. So now we know all of the sides for all of the triangles. What we want to find now is the angle BCA. So BCA is this angle over here. How are we going to find that? How are we going to find the angle C? What can we use to find the angle C? I have the side C. I also have the angle B, which is 105. And I have the side B. So let's just use the sine rule. B over sine B is equal to C over sine C. So B is 18.74 all over the sine of 105 degrees. That is equal to the side C, which is 15, all over the angle C, which is what we want to find. Right? So now we could cross multiply to get the sine of C is equal to 15 times the sine of 105, all divided by 18.74. Right? So 15 times the sine of 105 equals to that, divided by 18.74 equals to that. So now C is equal to the sine inverse of 0.7732. C is equal to the sine inverse of, answer is around 51 degrees. 50.6 degrees is what they have here. Alright, so C is ending up being 50.6 degrees. And let me look at this diagram. Let me draw over this diagram a little bit neater. Right? So we have A here, which is the 60 plus the 35. What I want is the bearing of A from C. So from C, this is the north line. That means that I want the bearing, which is this angle from the north line clockwise. This angle here. Yeah? So that is the angle that I want. Last question before we go home, guys. How do I get that angle? Remember this north line here. This angle here is 135. Yeah, but if this line parallel to this line, and we have this line coming here where this is A and this is C, then these two angles will be co-interior, and yeah, but that 135 is this whole angle here, not particularly this one. You understand?
Yeah, so both of them would be 90.
No, you cannot assume that at all. Right? You're on the right track though. But look, we have this. This is 50.6. We have this 105. So and we can find this tiny little one.
Yeah.
Alright? So 50.6 plus 105 is that, and 180 minus the answer gives me 24.4. So this little one is 24.4 degrees. So now we could say that this one here is what? 135 minus 24.4, that gives us 110. So this here is 110.6 degrees. So now we could say, well, all right, if this here is 110, this is north that is parallel to this. Yeah, so this is 110, The two of them are parallel, so therefore the two of them are co-interior. So now we could say 180 minus 110.6 gives us 69.4 degrees. You understand, Scotia?
Yes, sir.
Shazay, you okay?
Yes, sir.
Right? Now this is 69.4 degrees here. This is 50.6 degrees here. So we can add these two up, plus 50.6, and that gives us about 120 degrees. And therefore this bearing here now will be 360 minus 120, which is 240 degrees. If we go here, everybody seeing this?
Yes, sir.
Right?
Yes.
If we go here in, oh no, they're not in trigonometry, right? So, but we just finished trigonometry. I should upload this class video here. 5th class we have it on trigs, right? But the assignments are all the way up here, right? The first assignment, if you're looking past papers here, you're going to see this assignment, 2021 Mid-Year Review Part 1. So at the end of the day, it's 2 exams that you're getting, back to back. But the 2 exams are pretty much identical. I expect you to do bad in the first one, but I expect you to do good in the second one. Yeah, because they're pretty much identical, right? So this is the exam. There are a lot of questions. However, you should be able to cut through this exam. If you know your work, you should be able to cut through this exam in like less than 2 hours, right? So you can see here, I didn't even bother with a title. I didn't even bother with question numbers, because I just literally threw questions on the page. So I apologize for that. I was in a rush to get this done in time. But we have these questions here. BODMAS, we have indices, right? Then we have some standard form questions, right? So all of these are revisions to make us remember all of these stuff that we did, right? Make X the subject of the formula, here, right? We have a couple of algebra worded questions, right? We have to solve each one of these equations, simplify these guys over here, right? Rewrite the following expressions using only positive indices. So you're getting a little bit of work on indices here too, right? This here is a variation and proportionality question. Yeah, once you could see directly, varies directly, you're supposed to know, hey, that's a variation and proportionality question. Them 2 words, varies, well, the word varies, and you can either have directly or inversely is the other word you can have there, right? You simplify these guys, right? Then we get into circle theory, and we actually did this question today, so yay, right? Then we have a stats question. We have a constructions question under here. We have to actually construct, right? Then we have an area and parameter question, and we actually have a volume question under here. I might have to check something for you in terms of this volume question, right? Then we have a sets question, and that is it. Alright, so that is it for this first exam. Look at the exam. It looks like a lot of questions, but really and truly, especially this first section, which is just hardcore algebra here, this first section you should be able to cut down real quick, because it's just one little tiny question. Like these questions are probably 10 seconds each if you know your work, right? So this is your midterm review. You're finding it under past papers.